How could people build huge stone cathedrals and impregnable fortresses without a single electric motor or crane? It seems completely impossible to us to construct buildings of such scale using only ropes, wood, and human strength. These majestic structures have stood for centuries, defying time and modern technology. The secrets of the ancient masters are hidden in details that we have forgotten to notice amid the noise of machines. In this video, we will reveal the forgotten methods that allowed ordinary people to create true architectural wonders. Watch the video to the end, and you will learn how builders defied gravity and erected arches at dizzying heights. Want to learn a secret that has been passed down from generation to generation and was long considered lost? In those distant times, there were no architectural institutes or diplomas as we understand them today. Craftsmanship was passed down from father to son through decades of hard physical labor. Training began at the very bottom and required enormous patience. A stonemason began his journey by simply chipping away at shapeless stone blocks. Only after many years of hard work was he allowed to perform complex calculations. Knowledge of proportions and loads was kept strictly secret within the guilds. It was a closed caste of people with unique design skills. The masters used the simplest tools to create the most complex geometric shapes. A regular compass and plumb line replaced modern computers and lasers. They understood the language of geometry on an intuitive level. Every line on the drawing had a deep practical meaning. Each stone in the cathedral wall was fitted by hand with jeweler's precision. The craftsmen used templates made of thin wooden boards to control the curvature of the details. Even the slightest deviation could lead to disaster in the future. Accuracy was the main guarantee of the durability of any structure. An error of a few degrees at the foundation stage was absolutely unacceptable. It could lead to the collapse of the entire massive structure many years later. Verticals were checked daily using a simple weight on a rope. This was the most reliable way to control the quality of the work. The construction of a single object often stretched over many decades or centuries. One master could lay the foundation, and his grandson would finish installing the spire. This required an amazing continuity of design and fidelity to tradition. People worked to create something eternal and truly meaningful. This approach to work is radically different from modern standards of rapid construction. The craftsmen of the past did not seek instant profit at any cost. They put their soul into every piece of granite they worked on. We can still see the results of their labor today. They understood that they were building for eternity, not for a single season. This required a special mindset and incredible discipline. Each worker felt responsible to future generations. Collective labor became a true act of creation. The secrets of mortar and stone-laying techniques were guarded like the apple of their eye. Apprentices took oaths not to disclose professional secrets to outsiders. This ensured a monopoly on quality construction throughout the country. Craftsmanship was the main asset in the life of a medieval builder. We are very interested in hearing your opinion. What do you think about the teaching methods of the ancient masters? Write about it in the comments. Be sure to subscribe to the channel to learn more about hidden technologies. Are you ready for the shocking truth about what held up the tallest buildings in Europe? Medieval construction would have been impossible without one hidden technology. People of that time solved problems that seem difficult even today. And they did it without modern materials and mechanisms. Before laying the first stone, builders erected entire cities out of wood. These temporary structures appeared before the walls and towers. They occupied huge areas around the construction site. Sometimes such wooden complexes existed for decades. Medieval scaffolding was not like modern lightweight metal structures. It could not be dismantled in a couple of days. These were massive structures made of solid and very durable oak trunks. Each element had a large margin of safety. The wood was not chosen at random. Oak was valued for its density and resistance to stress. Such beams could withstand enormous weight. That is why they were used for the most critical components. The wooden beams were fastened together with thick hemp ropes of special strength. These ropes were made specifically for construction purposes. They were resistant to moisture and friction. The knots were tied according to strict rules. These temporary structures could withstand the weight of thousands of stones and hundreds of workers. People, Tools and building materials could be on the platforms at the same time. The pressure was distributed evenly. This prevented collapses. The scaffolding literally enveloped the building under construction, becoming its temporary skeleton. It replicated the shape of the future walls and towers. The structure grew along with the cathedral. The higher the walls rose, the higher the scaffolding rose. They grew upward along with the stone walls of the cathedral. Sometimes the height of the scaffolding exceeded that of neighboring buildings. This made a strong impression on the city's residents. The construction site became the center of life. Special skill was required to create convenient spiral staircases for people. Straight staircases were too dangerous. The spiral shape saved space. It made the ascent smoother. Workers could use them to lift materials to great heights without risk. Stones, lime, and tools were delivered by hand. Every step had to be sure. A mistake could end in tragedy. The scaffolding was the most complex engineering system of its time. It took into account loads, wind, and the movement of people. Nothing was built by eye. Everything was based on experience. Carpenters worked closely with masons to achieve the result. Some were responsible for temporary structures, others for walls. Their work was inseparable. One mistake could ruin the work of another.
Hold! It's shifting. I feel it. The joint.
Often, special holes were left in stone walls to secure beams. The ends of the beams were inserted into these holes. This provided additional stability. Such solutions sped up installation. When construction was completed, the scaffolding was carefully dismantled for reuse. Wood was too valuable to throw away. The beams were sorted and transported to new construction sites. The material served for decades. Extra holes were filled with stone or left for future repairs. Sometimes they were reused. These niches can still be seen in old cathedrals. They are silent witnesses to the construction process. Each work platform had to be absolutely stable and reliable. People worked at great heights without safety equipment. The slightest sway was dangerous. Therefore, stability was constantly checked. A strong gust of wind should not have been able to bring down the entire structure. The scaffolding was designed with weather conditions in mind. Winds at high altitudes were particularly treacherous. This required a margin of safety. The use of metal nails was severely limited due to their high cost. Metal was valued and used sparingly. Nails were used only in extreme cases. Other elements bore the main load. Instead, craftsmen used a system of knots and wooden dowels. These connections were easy to disassemble. They allowed the scaffolding configuration to be changed. This made the system versatile.
Warping. Aye. The joints hold firm.
This allowed the entire structure to be both rigid and sufficiently flexible. The scaffolding did not break under sudden loads. It sprang slightly. This increased safety. The scaffolding could dampen vibrations from the work and movement of heavy loads. Stones were constantly being lifted and lowered. The movement was continuous. The structure had to withstand this. Without these wooden giants, no cathedral would have been completed. Stone walls could not grow without support. Scaffolding was the basis of the entire process. Without it, construction would have stopped. Carpenters were considered no less important specialists than the masons themselves. Their work was dangerous and difficult. Mistakes were not forgiven. Experience was valued above all else. Huge tree trunks were delivered to the construction site from distant forests. They were floated down rivers or transported by cart. The journey took weeks. The logistics were complex. Craftsmen carefully selected each tree to ensure it was free of rot. They examined the core and bark. Poor quality wood was immediately rejected. The risk was too great. Only the highest quality wood could withstand the enormous loads. People's lives depended on it. There was no room for compromise here. Quality came first. Preparing the materials for the scaffolding took many months. The wood was dried and processed. The beams were cut to size. Everything was done in advance. The safety of the workers depended entirely on the skill of the carpenters and the quality of the joints. Each joint was checked repeatedly. People trusted them with their lives. It was a huge responsibility. Any mistake in the calculations could cost the lives of dozens of people. Falling from a height left almost no chance of survival. Therefore, the work was taken extremely seriously. Fear was compensated for by experience. In the next chapter, you will learn how people made huge blocks float in the air. It seems like magic, but it is based on precise calculations. Do you think that building the scaffolding was more difficult than building the wall itself? You've definitely never heard of this unique secret of moving loads. The main assistant of the medieval builder was a huge wooden squirrel wheel. People constantly walked inside this mechanism, creating the necessary traction. This device worked on the principle of a modern tower crane. A person walking inside the wheel created enormous torque for lifting. This allowed stones weighing several tons to be moved smoothly. The rope was wound onto a powerful shaft, and the load was lifted to a height. The process required incredible coordination of the entire team. Lifting mechanisms were often installed directly on the upper tiers of the walls. This allowed materials to be moved vertically with minimal time loss. Builders constantly improved the design of their cranes for greater efficiency. Mechanics replaced hundreds of workers on the site. Special steel scissor clamps were used to securely hold the stones in place. The heavier the load, the tighter the clamp squeezed its edges. This simple system completely eliminated the possibility of a heavy block accidentally falling. Safety was ensured by the purely mechanical properties of the device itself. In addition to huge wheels, complex systems of blocks and pulleys were actively used. They allowed one person to lift loads exceeding their weight. The ropes for these purposes were hand-woven from the best hemp fibers. Every detail of the system underwent rigorous testing before work began.
Now, together, lift with your legs.
It is amazing how people understood the mechanics of weight distribution without complex calculations. They intuitively found the optimal points of force application for lifting. Experience was passed on from master to apprentice through visual examples. Practice was the only measure of truth on the construction site. Each wheel was designed for specific tasks and construction conditions. Carpenters created mechanisms that could work outdoors for years. Friction was reduced with ordinary animal fat or tar. This ensured smooth running and durability of the wooden parts. The people who worked on the wheels possessed enormous strength and endurance. Their rhythmic steps were transformed into continuous energy for creation. The work was often accompanied by songs to maintain the overall pace. The construction site resembled a huge, well-coordinated anthill. The mechanisms of that time were surprisingly reliable and easy to repair. Any broken part could be replaced right on the spot. This allowed construction to continue without interruption due to technical problems. The ingenuity of the craftsmen knew no bounds when it came to solving complex problems. Like this video if you admire the ingenuity of the craftsmen of the past. They worked in harsh conditions, creating true architectural masterpieces. Each block lifted was a small victory of man over gravity. Don't forget to subscribe to the channel so you don't miss new videos.
Jammed again. Look there,
What you are about to learn will completely change your perception of reliability. Many people think that ancient walls are held up only by their own weight. However, the secret to their durability lay in the special composition of the lime mortar. It was prepared over a long period of time and according to specific rules. The lime was first burned in kilns and then slaked in pits. The slaking process could take months or even years. The longer the mortar was aged, the better its quality became. In some cases, it was stored for decades before use. Various organic components were added to the mixture for strength. These could be ordinary chicken eggs or whey. Such additives made the mortar more elastic and resistant to moisture. As it hardened, it turned into a real artificial monolith. Over time, the lime mortar only gained its main strength. It slowly absorbed carbon dioxide from the surrounding air and hardened. Modern concrete often begins to crumble after only 50 years of use. Medieval joints, on the other hand, remain completely intact and strong. The masonry process required the master to understand how the mortar behaved in the heat. In extreme heat, the walls had to be constantly watered with clean water. This prevented the binding mixture from drying out too quickly and cracking. Proper care was the key to the reliability of the entire future structure. In winter, construction often stopped completely for objective reasons. Severe frost could easily destroy the still unset masonry joints. The craftsmen waited for stable, warm weather to resume the main work. Seasonality was an integral part of the life cycle of a large construction project. The correct ratio of sand and lime was determined by the master craftsman by touch. This intuitive method allowed him to create the ideal proportions for each wall. Experience allowed him to take into account the moisture content of the sand and the quality of the raw lime. The chemistry of the process was mastered through many years of daily practice. This technology allowed buildings to withstand even strong earthquakes. The elasticity of the mortar dampened dangerous vibrations and prevented the walls from collapsing. The monolithic structure of the cathedral became one with its foundation. This provided incredible strength for many centuries. The craftsmen knew the secrets of additives that made the mortar frost-resistant and strong. Often, the recipes were kept secret within a single family of builders. The use of local materials saved on logistics without compromising quality. Construction was deeply integrated into the local natural environment. In the next chapter, you will learn how ancient builders coped with this terrible weather. It was a daily struggle to preserve the results of their hard work. Would you like your house to be built using this technology? Protecting the building under construction from water was the master builder's primary task. Moisture could destroy the results of their labor in a matter of years. That is why the issue of water drainage was considered even before the main work began. A mistake in this matter was considered fatal. Builders understood perfectly well that stone was not afraid of time, but of dampness. Constant moisture destroyed the binding mortar. Over time, it penetrated deeper and deeper into the masonry. Therefore, combating water was the basis of durability. The roofs of cathedrals and castles were covered with lead sheets or tiles. These materials were chosen for their resistance to precipitation. They served for decades without replacement. The roof was considered the first line of defense for the building. Each element of the roof was attached by hand with the utmost care and attention. The slightest mistake could lead to a leak. The craftsmen worked slowly and carefully. Quality was always prioritized over speed. Water had to flow down freely without getting stuck in the gaps. Any accumulation of moisture was considered dangerous. To achieve this, the correct roof slope was set. It was calculated taking into account the climate of the region. The famous gargoyles and gutters were used for effective drainage. They were not just a decoration of the facade. These elements were part of a well-thought-out engineering system. Their shape had a strict purpose. These decorative elements performed a vital engineering function on the facade. They directed water in the right direction. The streams did not run down the walls. This protected the masonry from erosion. They threw streams of rainwater far away from the walls and foundation. The further the water went, the better. This reduced the moisture content of the building's foundation. Moisture was considered the main enemy of the durability of any stone structure. The foundations of buildings were laid at a very great depth for stability. The depth made it possible to avoid seasonal soil movements. The base had to be immovable. Without this, protection from water lost its meaning. In marshy areas, craftsmen used tightly driven oak piles. They were driven into the dense layers of soil. This technology was known long before modern engineering. It proved to be surprisingly reliable. Deprived of oxygen in the water, the wood became as hard as steel. It did not rot or decay. The piles served for centuries. Great cities still stand on these invisible supports. Proper ventilation of basements also helped to successfully combat destructive dampness. Air had to circulate freely. This prevented moisture from accumulating. Basements remained dry even in wet weather. The walls were made very thick, which provided excellent thermal insulation all year round. The thickness helped to maintain a stable temperature. Sudden changes in temperature were harmful to the stone. The massiveness acted as protection. Inside such rooms, a stable and dry microclimate was always maintained. The stone did not get damp. The mortar retained its strength for longer. This prevented the appearance of mold and the gradual destruction of the stone. Craftsmen took into account the wind rose when designing entrance groups and windows. They knew where the rain most often came from. They tried to protect the entrances from direct wind. This reduced the amount of moisture getting inside. This minimized the amount of snow and rain that entered the building. Even in severe weather, the rooms remained dry. The architecture was adapted to the climate. The building seemed to cooperate with nature. The use of special water-repellent compounds helped protect the decorative carvings on the facade. The stone was covered with protective layers. They repelled water and dirt. This preserved the appearance of the building. Every detail was aimed at preserving the building in its original form. The decorations were not superfluous. They also needed protection. Beauty and practicality went hand in hand. Particular attention was paid to sealing the joints between the massive stone blocks. The joints were the most vulnerable spot. Water penetrated through them most quickly. The craftsmen knew this from experience. The durability of the buildings was the best proof that they had chosen the right path. Many buildings still stand today. They have survived the climate and wars. That speaks for itself. Architecture was a true art of protecting human space. It protected people from cold, water, and time. That was its main strength. Guess how long it took the craftsmen to learn how to build such ceilings? This skill did not appear in one generation. It was formed over centuries through mistakes, collapses, and new attempts. Each successful vault became a lesson for future builders. The construction of arches was the true pinnacle of medieval engineering at that time. It was considered the most difficult stage in the construction of any large building. Not every master dared to take on such work. The reputation of an architect depended precisely on the success of the arches. It required mathematical precision and a deep understanding of the laws of force distribution. The formulas existed more in the mind than on paper. Calculations were based on experience and observation. An error in one corner could change the behavior of the entire structure. Any error in the calculations led to the instant collapse of the structure. Stones fell down, destroying months of work. Sometimes people died. That is why arches were treated with special fear and respect. Temporary wooden frames, called centering, were used to support the heavy stones. These structures replicated the shape of the future arch. They held the stones in place until the mortar had completely set. Without centering, construction would have been impossible. The formwork was made of strong wood and carefully fitted to the shape. Any unevenness could lead to distortion. Carpenters worked with precision. Their contribution was no less important than the work of the masons. The stones were carefully laid in an arc on both sides simultaneously. This allowed the structure to remain balanced. The work proceeded slowly and strictly in order. Rushing here was deadly dangerous. The most important element was the keystone, installed at the very end. Its shape differed from the other blocks. It was inserted into the arch with force. This moment was considered the culmination of all the work. It was this stone that completed the entire structure and held it together. After it was installed, the load was redistributed throughout the arch. The vault began to function as a single unit. It was a moment of tense anticipation. When the temporary supports were removed, the vault settled slightly downward. The stones took their final position. Sometimes this was accompanied by cracking and sounds of tension. The craftsmen watched every movement closely. The enormous weight of the ceiling pressed not only downward, but also sideways. This lateral pressure was particularly dangerous. It tended to push the walls of the building apart. Without protection, the walls quickly cracked. To prevent the walls from separating, the builders devised a system of powerful external supports. These elements became an integral part of the architecture. They took on the main load. This is how the building remained stable. The buttresses took on this enormous lateral pressure. They were made massive and heavy. They seemed to grow into the ground. It was they who kept the temple from collapsing. In Gothic architecture, this system became open and very elegant. Engineering elements were no longer hidden. They began to be emphasized and decorated. The structure became part of the beauty. Flying buttresses appeared, transferring the load from the arches to the external pillars. They seemed to transfer force across the void. It looked bold and unusual. Architecture found a new language. This design allowed for thinner walls and larger windows. Stone no longer had to be a solid mass. Glass took on an important role. The space became lighter. Buildings were filled with light and a feeling of incredible airiness. Interiors were no longer gloomy. The height of the arches enhanced the impression. People felt like they were part of something grand. The arches could have the most complex shapes, resembling stars or floral patterns. This required even more precise calculations. Every curve was important. The decor became part of the structure. The craftsmen calculated the trajectories of forces using simple models made of threads. They suspended chains and observed their shape. This method gave surprisingly accurate results. Practice replaced formulas. They studied the shape that a heavy chain took under its own weight. This line was considered ideal for an arch. It showed the path of force. The inverted shape of the chain became a blueprint. The inverted shape of the chain provided the ideal outline for the future arch. Stones were cut according to it. Each block had a strictly defined place. An error in one element would disrupt the entire balance. This made it possible to create huge open spaces inside temples without columns. The halls seemed endless. Nothing obstructed the view. The architecture worked on emotions. People felt the grandeur of the architecture while standing under such unstone heavens. The height was awe-inspiring. The space was both overwhelming and inspiring. This was part of the plan. The technology required masterful tool handling and a keen eye from every mason. There were no machines. Everything depended on skill and experience. Mistakes were not forgiven. Each block of the vault had its own unique shape. It could not be replaced by another. The stones were fitted directly on site. It was work of the highest caliber. The craftsmen carefully selected light stone types to fill the cavities in the vault. These areas did not bear the main load. Weight was saved there. This reduced the overall pressure. This made it possible to reduce the overall weight of the ceiling without losing its strength. The structure became more stable. Less weight meant less risk. Such solutions were considered a sign of craftsmanship. The use of hollow ceramic vessels was also a common technique for lightening the load. They were laid inside the masonry. They were not visible, but they played an important role. Builders were constantly looking for ways to improve their designs. Each cathedral became an experiment. Successful ideas spread. Mistakes were not repeated. The process of removing the formwork was the most critical moment in the entire long construction process. This day was awaited with anxiety. Sometimes it was postponed for weeks. The decision was made by the master builder. The master had to personally make sure that the mortar had gained the necessary strength. He checked the masonry by hand. He assessed the color and density. Experience replaced instruments. The supports were lowered very slowly and evenly across the entire area of the vault. Sometimes it took several days. No sudden movements were allowed. Patience saved the building. This prevented dangerous distortions and cracks in the masonry. The vault had to take the load gradually. Only then would it become strong. It was the moment of truth. Cathedral vaults have stood for centuries without any additional steel reinforcement. There are no hidden reinforcements in them. Everything is held together by its shape. This is still impressive today. They are held together solely by correct geometry and compressive strength. Stone does not like tension, but it works perfectly under compression. The craftsmen took advantage of this property. This proves the genius of the simple solutions found by ancient architects in their work. They did not complicate things unnecessarily. Their solutions were logical. That was their strength. We still admire their courage and skill. These buildings have survived wars and disasters. They continue to stand, and they teach us respect for engineering. In the next chapter, you will learn how they coped with the lack of lighting. This was a separate challenge for the architects of that heroic era. Would you trust your life to a structure held up by a single stone? Lighting huge interior spaces was a difficult task for ancient architects. Windows in those days were not just openings, but complex systems. To prevent the walls from losing strength, the openings were made narrow on the outside and wide on the inside. This allowed them to capture maximum sunlight during the day. Craftsmen used the diffusion effect to distribute light evenly throughout the hall. Glass was an incredibly expensive and rare material in those days. Its use in construction was considered a sign of supreme power and wealth. Stained glass windows created a special, almost magical atmosphere for parishioners inside cathedrals. Colored glass was made by hand with the addition of secret metal oxides. The installation of huge glass panels required the creation of strong lead bindings. These frames had to withstand strong wind pressure at height. Each window was a unique work of art by many talented craftsmen. The light inside the cathedrals seemed majestic and completely unearthly in its power. It changed depending on the time of day and the position of the sun. Architects precisely calculated the angles of incidence of the rays to illuminate the main altars. This required a deep knowledge of astronomy and optics. The location of the windows corresponded to the movement of the sun across the sky at different times of the year. The masters even took the winter solstice into account when planning the architectural elements. The light became a living part of the interior decoration of the majestic stone temple. Each ray was part of a grand and well-thought-out plan. The lower tiers of the buildings often remained in semi-darkness to create contrast. The main flow of light was directed to the upper part of the huge vault. This created the illusion of a heavenly dome hovering above people's heads. The psychological impact of the architecture was calculated down to the smallest detail. Candles and oil lamps complemented the natural daylight in the interior. Huge chandeliers descended from the ceiling on powerful chains for maintenance. Smoke and soot were a serious problem for the preservation of stone carvings. Craftsmen designed special extraction systems to remove combustion products. Precious metals and stones in the decoration enhanced the effect of bright lighting. Glare reflected off the golden surfaces, filling the hall with a warm, soft glow. Light was a symbol of the divine presence in this stone space. Architects knew how to work with it as a full-fledged building material. The size of the windows gradually increased with the development of the master's construction engineering ideas. Late Gothic architecture gave the world huge openwork roses and panoramic windows. The walls practically turned into a thin stone frame for fragile glass. It was the pinnacle of mastery in the management of light and space. We are still studying these methods of light control in architecture. Ancient craftsmen left us an incredible legacy of visual effects and solutions. The ability to see beauty in the play of light and shadow remains relevant today. Every trip to an old cathedral turns into an amazing discovery. The medieval builder's arsenal consisted of simple but extremely effective tools. Almost all of them were made by hand by blacksmiths right on the construction site. The main tool was an ordinary measuring rope with pre-tied knots. Set squares and compasses helped to transfer complex drawings from parchment to stone. Each craftsman cherished his tools as his most valuable possession. These items were an extension of the builder's hands and allowed him to achieve precision. Various types of chisels, mallets, and axes were used to work the stone. Rough cutting was done with heavy hammers, and the final finishing touches were made with chisels. Masons were able to determine the quality of the material by the sound of a light hammer blow. This allowed them to weed out blocks with dangerous internal cracks in time. The axe was used to work with wood and some soft types of stone. Simple iron saws allowed them to cut even slabs with minimal waste. Working with such tools required enormous patience and great physical strength. Modern craftsmen are often amazed at the quality of the finish achieved by hand. Every mark left by a chisel preserves the memory of the work of a particular person. These tools created the face of Europe as we know it today. Particular attention was paid to sharpening and hardening the metalworking tips of the tools. Blacksmiths were always close at hand to make minor repairs immediately. The speed of work and the quality of each detail depended on the sharpness of the tool. Craftsmen knew the secrets of working with steel for different types of stone. The levels of that time worked on the principle of communicating vessels with water. This made it possible to set perfect horizontals over huge distances on the construction site. The simplicity of the solutions was combined with the incredible accuracy of the craftsman's final measurements. Errors in marking were minimized thanks to constant rechecking. Massive lead plumb lines on strong cords were used to measure verticals. This ancient method remains the most reliable to this day. Gravity was the only and most honest controller on the construction site. The walls were erected with impeccable adherence to the vertical axis of the structure. The craftsmen themselves designed and created templates for complex stone carvings. The templates were made of dry wood or thick sheet material. Dozens of masons worked according to these samples, ensuring complete unity of style. Standardization helped to speed up the process of erecting huge architectural ensembles. Tools were transported to the top in special woven baskets. Each worker was personally responsible for the safety of his own toolkit. The breakage of an important tool could stop the work of an entire team of builders. Thriftiness was the basis of professional ethics in those harsh times. We admire the results of the labor of people armed only with simple iron. Their patience and faith in their work created real miracles. Today, these tools are kept in museums as witnesses to a great era. They remind us of the value of manual labor and craftsmanship.
Foundation here must...
Supplying a huge construction project with materials required incredible organizational efforts on the part of the management. Construction did not begin without a clear understanding of where and how resources would come from. A mistake in logistics could halt work for months. Therefore, supply management was considered no less important than the construction itself. Stone was quarried hundreds of kilometers from the city. Often, there were simply no suitable rocks nearby. The best materials had to be chosen, even if the journey was long and difficult. The quality of the stone directly affected the durability of the building. Huge blocks were transported along rivers on special cargo barges. Water allowed for the transport of significantly greater weight than land. Sailing was slow but relatively reliable. Rivers became the main transport arteries of medieval construction. In winter, traveling on ice by sleigh was more efficient and faster. Frozen rivers turned into convenient roads. Heavy blocks slid more easily on ice. The cold season was actively used for transportation. Thousands of people were involved in harvesting timber and burning lime. Some felled trees, others sawed and dried logs. Still others were engaged in the production of building mixtures. Construction drew in a huge number of workers. It was a giant economic machine that fed entire regions of the country. People received work, food, and protection. Settlements and markets sprang up around large construction sites. Construction became the center of life for decades. Each stone was marked with the personal stamp of the master craftsman for strict accounting of the work. This made it possible to track the quality and volume of the task performed. The master was personally responsible for his section. This system reduced the number of defects. In the quarry, the blocks were hewn in advance to save weight during transportation. Excess stone was removed immediately at the extraction site. This reduced the load on transport. Only what was really needed was transported. This required precise planning of deliveries many months and years in advance. The dimensions of the blocks had to match the project. Any error in dimensions made expensive transportation completely pointless. It was almost impossible to correct it on site. A delay in one material could stop the entire chain of work. Bricklayers waited for stone. Carpenters waited for beams. Downtime was very expensive. Therefore, planning was carried out with a large margin. The wood for scaffolding and flooring underwent a long natural drying process. It could lie under awnings for years. This reduced the internal tension in the wood. Dried wood was more stable. The use of raw wood could lead to dangerous distortions of the entire structure. Beams deformed over time. This created a risk of collapse. Experience told the craftsmen not to rush. The entire complex supply chain was controlled by the master builders on site. They monitored deadlines and quality. Their decisions affected the progress of the entire construction project. It was a huge responsibility. They knew the needs of a huge construction project decades in advance, according to the schedule. The design was carried out with the future in mind. The craftsmen understood what materials would be needed later. This made it possible to avoid crises. The scale of this invisible work often escapes the eye of the ordinary viewer. We only see the walls and towers, but we do not notice the path of each stone. This work remained behind the scenes of history. Behind every majestic building was the labor of an entire people. Thousands of people invested years of their lives in it. Construction was a common cause. That is why such buildings have survived for centuries. The final stage of construction was the careful finishing and protection of all surfaces. The walls were covered with a thin layer of plaster or ordinary lime whitewash. This protected the porous stone from destructive weathering and moisture. The craftsmen knew that regular maintenance would prolong the life of the structure for centuries. The roofs were regularly inspected by experienced roofers for possible leaks. Attention to detail allowed the buildings to remain functional for many generations of people. Many buildings still stand today because they were inhabited. People constantly maintained their homes and temples in working order. The internal structure of the walls provided excellent resistance to various vibrations. Buildings were designed so that they could be easily repaired over time. Access to important structural components always remained open for inspection. Looking at these walls, we see the result of people's belief in eternity. Modern engineers have much to learn from those who built without computers. The true value of these structures lies in the knowledge and will of their creators. We continue to admire their courage and ability to overcome any difficulties. Each such building is a monument to human genius and perseverance. The correct distribution of loads within the foundation played an important role in longevity. The builders took into account the composition of the soil under the future massive structure very accurately. The foundation of the cathedral became a single monolith with the surrounding soil. This prevented dangerous distortions and cracks in the walls. The stone for construction was selected based on its resistance to the local climate. The builders knew the properties of each type of rock extracted from the old quarries in the surrounding area. The exterior cladding was always made of the hardest and most durable materials. This created a reliable protective shell for the entire internal structure of the building. Particular attention was paid to protecting decorative elements from the destructive effects of wind. Sculptures and carvings were often covered with special protective wax compounds. This helped to preserve the fine lines and smallest details of the work for a long time. Beauty had to be not only majestic, but also durable. Many secrets of stone conservation are still being studied by modern restoration scientists. Ancient compounds are surprisingly effective in combating atmospheric corrosion. The craftsmen of the past had a deep empirical knowledge of materials chemistry. Their experience is an invaluable contribution to global building culture. Continuity in building maintenance allowed any minor damage to be noticed in time. Each community had its own craftsman responsible for ongoing repairs. The cathedral was not perceived as something complete. It required constant attention. This living interaction between man and stone has been going on for centuries. We continue to study these architectural monuments, uncovering new secrets. Each generation finds its own answers to eternal questions in them. The resilience of these walls inspires us to create something truly important. The history of construction is the history of the triumph of the human mind over matter. Today we have touched upon the amazing world of medieval construction and craftsmanship. We have seen how complex and well thought out the solutions of people living without modern technology and materials were. These technologies remind us of what a person with willpower, patience, and a vast store of knowledge is capable of. Behind every stone, beam, and arch were years of experience and collective labor. Medieval craftsmen created not just buildings, but a legacy that has survived the centuries. We often underestimate the past, considering it primitive and uninteresting. But the deeper we delve into it, the clearer the scale of human capabilities becomes. These people knew how to work to the limits of their physical and intellectual abilities. Do you think we could repeat such a feat of labor today? Suggest topics for our future videos about the mysteries of the past in the comments. Be sure to subscribe to our channel so you don't miss out on new, interesting research.